So hello guys, welcome to the runtime error, the place where programming begins. So today we are going to solve a Leetcode problem of the day solution that is called a number of good pairs. So let's check what does the question mean is. So what they have told is we have given an array of integer called as a nums and we need to find the good pairs. Now the question comes, what do you mean by good pair? So what they have told is if nums of I is equal to nums of j such that j is greater than I, then they are called as a good pair. So simply we need to find a number of good pairs in particular array. Let's say for example we have given a particular array. I have took this example so that I can explain you in more detail. Now we can say that this one and this one are both are equal, therefore 0 and 3 both are equal, right? That is these 3, and again this one is equal to this one, so it would be 0 4, that is these 2, and again these two are also equal, that is 3 4, and again these 3 is equal to this 3, so that is 2 5. So what are the total number of pairs possible? There are total 4 pairs are possible. And most interesting point to note that they have mentioned that j should be greater than I, and as you can see 3 is greater than 0, 4 is greater than 0, 4 is greater than 3, and 5 is greater than 2. So this is the meaning of the question we have looked upon. So I hope so you got the pure meaning of question. Okay, now let's look at the brute force solution for this problem. So what we need to find is we need to find the good pair. So can I say this one is equal to this one is also equal to this one, right? 2 is not equal to any one of this, 3 is equal to this 3, and this one is equal to this 3. So simply what I will do is I will compare all the elements with these elements. So these elements will be compared with this one. Now again what I will do is with this 2 I will check all these elements, and for this 3 I will check all these elements. So for every single elements I am going to check every other remaining elements. Therefore how we can do this? I will run a 2 loop, that is 1 from 0 to n minus 1, because I need to start from this index, right? And another loop just to check the remaining one. Therefore I will use j equal to I plus 1. Why I plus 1? Because in a question it is clearly stated that j must be greater than I. And this will also go till n minus 1. And simply I will check if my nums of I is equal to nums of j, then I will simply increment the counter, and finally I will return count, and the count will contain my final answer. For this one, that is this one is equal to this one 1, so it becomes 2, then it become 3, and this become 4. Therefore total answer will be for this question will be 4. So what will be the time complexity if you discuss for this? For sure it would be big of n square, because for every single element we are checking remaining elements for this, for this and this. Therefore total time complexity would be big of n square. So I hope so you got the brute force solution. Let's look at the optimal solution for this question. Now say for example I am present over here. Now how many pairs are possible with this one? Exactly 1, because before this one there was exactly one was present, right? And if I come across here, how many pairs are possible with this one? That 1 and 2. Then can I say for example I'm at over here, the number of pairs possible at this position will be equal to total number of occurrence of 1 to its left, right? Total number of occurrence of to its left. Say for example I'm at over here, the total number of pair with this 3 is possible with total number of occurrence of 3 to its left, that is exactly 1. Therefore total number of pair is possible exactly 1. For this one there are 2 ones are present, therefore total number of pairs will be 2, right? So can we say that number of pairs for x equals to number of occurrence of x to its left, right? Means if I'm at here, total number of pair with this one will be 2, because there are 2 one possible to the left of this one. So this is what it means. So what it will help us to keep a track how many ones or twos or threes are possible to its left. So can we say we can use a hash, so that we can store the occurrence of those elements. Say for example this is my hash. So what I will do is I will traverse through my array, and I will check if this one is present in my hash, if these two present in my hash, and if it is, what is the total number of occurrence. Now I will start with 1. Does my hash contains 1? No. So I will simply store 1 with its occurrence as 1. Now I come across 2. Is my hash contains 2? No. So I will simply store 2 which occurrence as 1. Now I come across 3. Is my hash contains 3? No. So I will simply store 3 with occurrence 1. Now I come across 1. Now I come across 1 and I will simply check, is my hash contains 1? Yes, it contains 1. Then what is its occurrence? 1. Therefore, how many numbers of pairs are possible with this one? Exactly 1. Because to the left of this one, there is exactly one is there. Therefore, only one pair is possible. Therefore, my counter will contain is 1. And since my this one has come, I will simply increment its counter to 2. Now again I come across this one and I will check, is my hash contains 1? Yes. How many occurrence of 1 is there before this one? 2. This is 1 and 2. Therefore number of pairs 1 and 2. Therefore I will simply increment this counter as 2. And I will erase this, and since this one has come, so again this occurrence will be 3. Now come across this 3 and I will check, is my hash contains 3? Yes. How many occurrence of what 3 before this 3? Exactly 1. Therefore I will put it 1 and simply it got upgraded to 2. So since I ended with my array, so what will be my final answer? My final answer will be 4. So this is the optimal solution. This is the optimal solution. Now let's look at the code for this. So this is the C++ code and this is the Java code. You can check according to their own convenience. So what I did is I declared the variable count which is initialized to 0, and I declare the hash map over here. In C++ we use unordered map, whereas in Java we use map itself. Then we traverse to the array and check if that element is present in my hash. If it is no, then we simply incremented its counter by 1. Similarly we did in Java too. If that element is present inside my hash already, then I will simply increment its counter to my count variable, because as I told you that if I'm over here, a number of occurrence of 1 before this 1 is 2, therefore total number of pairs 1 and 2. The same thing we did over here, that is occurrence is incremented in count variable, and again I inserted that element in my hash itself, and finally I return count. So this is the optimal solution. If we discuss the time complexity, it would be big of n, and space complexity would be also big of 1, because in worst case, say for example my array contains 1, 2, 3, 4 and 5, so I need to push all the elements in my hash. Therefore my space complexity in worst case would be big of n, and time complexity would be big of n, because we are traversing the array exactly once. So I hope so you understood this question more clearly. In order to know more about Leetcode problems, do subscribe the Runtime Error.